So now we'll be solving question number 60 from the phase 1 chapter called Forces and the Laws of Motion. This is in the exercise 1. Okay, let's read the question. Two bodies of masses 4 kg and 3 kg respectively are connected by a light string. The string is light and obviously massless, passing over a smooth frictionless pulley. If there is a light string passing over a smooth frictionless pulley, then the tension throughout the string will be same. We have to calculate the acceleration of the masses and the tension in the string. Okay. What I'll do in this case, I'll not directly use the formula. I'll be solving it. Okay. So that you'll get the idea as well. We can use the formula as well. So let's say this is the case. One body mass is M1, other body mass is M2. M1 is 4 kg and M2 is 3 kg. So M1 is more than. First, I'll write the formula. Okay. Since M1 is more than M2, M1 will be going down with acceleration A. So because of constraint relation, M2 will be going up with the same acceleration. The tension in both cases will be same in upward direction. So I'll write the formula first. To calculate the acceleration, that will be coming out to be M1 minus M2 G divided by M1 plus N. And when you calculate the tension, it will be 2 times of M1 M2 G divided by 1 plus N. You are supposed to remember these formulas because this is a very simple case and very frequently in easier exams they keep asking. So directly you can get the formula by putting the values of F here. But I'll be solving it. I'll see how to get these formulas. Okay. So this mass I'm saying 1 and this mass I'm saying 2. So I'll make the FBD of 1. So this is my system. So I'll be making the FBD for this system. Let's make it. So the number of forces acting on it is 2. So M1G will be acting downward, gravitational force, driving force which is, and the tension will be acting up, which is a resisting force. This whole system I have assumed is moving downward, so it's moving with A. So direction of acceleration will be taken as positive by default. So my equation in this case will be M1G, which is positive because it's in the direction of acceleration, minus of T. This minus is because opposite to direction of acceleration is equals to M1 into A. This is the equation we are getting from first FBD. Now I'll go for the second FBD. I'll make this FBD of second one. So M2G is acting downward, tension is acting up, the system is moving up with acceleration A. Now since acceleration is A in upward direction, upward will be positive this time. So any force which is upward will be taken as positive and downward will be taken as negative. So the equation will be T minus M2G is equals to M2 into A. This is equation. Now you can see tension is unknown and acceleration is unknown. So there are two unknown and there are two equations. By solving these two equations, we'll be able to calculate the unknown. So what I'll do first, I'll add these two equations. If I add equation 1 and equation 2, here the tension is in the negative, here the tension is in the positive. They will cancel out. Upon adding, you get M1 minus M2 G is equals to M1 plus M2. And from here, I'll be getting A as M1 minus M2 G divided by M1 plus M. Now this value of acceleration, if I put in the equation 1 or equation 2, so if I place the A, let's say in the equation 1, and then I'll be taking this right side of this on the left side, I'll be able to calculate the tension, which will be 2M1 M2G divided by M1 plus N. As you see, this is how we get the equations. Okay. Now, for this question, I'll be solving it. The mass M1 is 4 and M2 is 3. So I'll put the values. So acceleration will come out to be 4 minus 1, G, which is 10, divided by 4 minus 3, and 4 plus 3. That is going to be 10 by 7 meter per second square. The acceleration will be coming as 10 by 7 meter per second square. Then if I go for this question, I'll again write the values. To calculate the tension, it will be 2 times of M1 into M2, which is 3, into G, which is 10, divided by M1 plus M2, which is 7. So 240 by 7, we are getting Newton. We can further solve it. We want the answer in the decimal format. We can further solve it. Approximately 3. So 34.3 Newton. Somewhere close to that, you'll be getting the answer. Okay. So in this question, we have seen the Pulley mass problem. We did the derivation as well. And these values you are supposed to remember for this simple Pulley mass system case. Okay. Thank you.